Good morning, everyone. Today we are going to talk about the topic computer organization. So, this is for class 11 computer science, chapter 3. So, the main learning objectives of this tutorial would be understanding what is computer organization, learning about the processors, understand memory devices, what is the difference between RAM and ROM, which is random access memory and read only memory, and what is cache memory, understanding the storage devices and ports. So, the computer organization deals with hardware components, which includes a CPU, input output devices, storage devices, and memory. How these things are interconnected and worked with each other. That's what we will be seeing in the computer organization. So it clearly explains how these components work together. So what is the difference between computer organization versus architecture? Computer organization is, like I said, the hardware components, which could be CPU, mouse, keyboard, monitor, and their connections or interconnections. Computer architecture, on other hand, means design and engineering of computer systems. Okay, those are two different terms with two different meanings. So let's talk about microprocessors. What is a microprocessor? Microprocessor generally means a chip that is programmable and it processes the data in the binary format. Okay, so this is the symbol of the microprocessor. So how does the microprocessor work? It receives the input from the user, process it, and then produce it as the output. Here the microprocessor and CPU is a similar term. Microprocessor is the chip where the CPU resides. Okay, so there is the image on the right bottom. It clearly shows how the microprocessor interacts with user input and how does it interact with the memory to fetch, retrieve and store information in the memory and then deliver it to the output. So let's look at the components of microprocessor. The diagram in the right side shows the existing components in a microprocessor. ALU, which is arithmetic and logical unit that performs mathematical and logical operations. Control units that acts as a controller here for the microprocessor. And then the register array, it's more like a storage, but in the binary form, right? That is what registers are used for. So once it receives the information from the input device, the controller decides on what to do and then process the information and then produce it to the output device for the user to see. On the right hand side, the the components of the microprocessor are explained here, which is ALU, performs arithmetic and logical operations. As we all know, those are mathematical operations. It could be as simple as addition and um, further doing multiple complex operations, right? And then the control unit, it controls whatever that is happening in the microprocessor. Register array, which is the registers that is used as a temporary storage inside the CPU. Okay, I hope you got what is a microprocessor and what are the components of the microprocessor. So microprocessor is a silicon chip. Okay, what are the characteristics of microprocessor? So the cost of the microprocessor is determined based on the speed and the number of instructions that it can perform at a single second, and during processing those instructions, how much longer the instructions that a particular microprocessor can process, right? So those are the characteristics that we will look for while buying a computer, a laptop or whatever, right? Those devices, computing devices. So we have what, the Intel i7, i5 and i3. We moved from i3 to what, i5, i7. Now I think we are at the stage, we use AMD and then the other microprocessors, um, which are much more faster. And we have for gaming they use AMD, right? That is for a specific purpose. And then for programming, I think starting from Intel i7, it's doing well, and you could go as high as i11, I think, these days. And let's talk elaborately about these characteristics. Clock speed. Clock speed determines how fast the processor executes instruction. Okay, it's measured in megahertz or gigahertz. How fast? What is an instruction set? A set of commands that a processor can execute, which includes the instructions could be anything, right? It could be as simple as entering a word in a letter in a Word document. It could be like retrieving data from the memory, performing arithmetic operations. So it includes data transfer, arithmetic, logical, input output operations. It could be any of those. Then the word size, like I said, the number of bit processed in one instruction. Okay, so that is the word size. Like it could be in 8 bit, 16 bit, 32 bit, or 64 bit. CPU and memory communication, and how it does communicate. Like we saw before, computer organization is pretty much the interaction of the hardware components in the computing device, right? So CPU and memory communication is how the CPU and memory interacts with each other to retrieve the already existing information in the memory, or storing the new information in the memory, right? So what is MER? Memory address register. What is MDR? Which is memory data register. PC is program counter. These are the low level terms, right? How in registers and all, it stores information, right? Once it's stored in one address, then it will go to the counter will increase, so you will go to the next address and then store the next information there. So counter is more like in the loops and all, you see counter, right? for I equal to 0, I less than 10, I plus plus. I plus plus here is a counter, right? Once the loop executes, after the last line, the counter will increase, which means I will increment to 1, 2, and so on. Counter is incrementing a value. In this case, a memory address, right? Okay, memory data register is where we really store our data. Data could be anything, right? It could be a Word document, or it could be the um, operations and their values and whatnot. Images, it could be video. So those are the data, right? What is the memory address register? Address is the location in which the data is being stored. Okay, let's just say there is a plate, that is an address. Okay, in plate we store a cake, or a rice or something, or any food item. So the food item could be here, it's pretty much an equivalent, guys. Food item here is memory data register, which is a data, and then the address is the plate in which we are. It's an location, more like a our house address, right? So we identify where I will be based on my house address, right? Consider myself as a data. So I'll be there in my address, which is my home address. Similarly, we need address of our files so that we can go and fetch in that address. Let's just say I have a folder. In that folder, I have a particular file. Let's just say gomati.docs. I have to go to that folder to fetch that file. If I go to a different folder and check that, it won't be there, right? So you need address for memory as well, just like in the normal life, to fetch the correct data. Or sometimes you want to store new information in that particular address. So MAR is as important as the data, or it is much more important than the data itself, because you want the address to fetch the data. Otherwise, yeah, we have things like when the storage devices, hard drive devices, where the pin needle move, you will not be able to fetch those data, right? It's you cannot retrieve those because the address is lost. So without that address, without that needle, we cannot be able to fetch those data. I hope I have given you an idea of what an address is, right? And why it is essential. So look at these different registers that are used, and their full form and their function. MAR is memory address register. It stores memory address. MDR is memory data registers, stores data being transferred. PC is program counter, stores the address of the next instruction. Okay, so using the program counter, we can go to the next address where the instruction is being stored. Okay, let's look at the bus system. Bus is a set of wires used for communication. In simple terms, these are link wires, like the internet link, that is a bus, right? The physical cable between your internet device and your laptop. What is an internet device called? It's a modem, right? So a wire that connects the modem and the laptop or your PC, that is a bus. That is an excellent example of bus. Okay, which is used for communication between the modem and then the laptop or computer, which we use to connect to the World Wide Web, right? So all the connection devices or the wires, you can say it a bus. So in there are three images that I have given, right? The connection cables are one bus, and then the motherboard buses. As you can see in the motherboard buses, there are these lines, right? You can see, right? Those are the buses that transfer information from one point to another in the motherboard. So here are, in the third image, there are some more examples of connection cables. Okay, so connection cables are an example of bus system of any bus. So there are types of buses, that is data bus, address bus, and control bus. So data bus carries the predominant information that is carried in the data bus is data. Address bus has the address, and the control bus have instructions that are needed to be used to control the instruction set. Okay, then the microprocessor classification. So the microprocessors can be of different types based on the data width, right? um so the data width could be like, as you can see here, it could be 8-bit, 16-bit, 32-bit, and 64-bit. So based on the instruction set, the classifications are RISC, which is reduced instruction set computer, and then CISC, computer complex instruction set computer. So there are different types of microprocessor. These are the two of them. And then the memory devices. So we know memory devices, right? It stores data and instructions. So how do you access these information? Through sequential access or random access. Okay. The memory devices, give me some examples of memory devices. It could be, what, flash drive is a memory device, right? The pen drive. What else? Hard drive, that is a memory device. What else? External hard drive, internal hard drive, and so on. So let's go through the sequential access and random access. So sequential access is the, from the memory the data will be fetched in a sequence as shown in the first picture. Random access is accessing the data in a random manner, which is also shown in the image. Okay, so sequential access is beneficial when the data that are needed to be retrieved is small, right? Because you have to go through, what if your data is in the sixth position, you still have to go through 1 2 3 4 5 and then the 6, so it will take time, right? Random access is another way of accessing these information. So the speed varies based on these two different access. Sequential access speed is slower, as I told you earlier. Even if your data is on the sixth position, it will go from sequence 1 2 3 4 5 6, so it makes it slower. Compared to sequential access, random access is faster. Okay, the access method in the sequential access is data accessed in sequence, data accessed directly. So the example of the devices are magnetic tape. Like I said, those are old technology, right? So the needle or the light, it go from one position to another and then it will try. But then the faster one is random access, which is the RAM and then the hard disk, external hard disk, which you could say. So what is random access memory? This is the main memory of a computer. It's a temporary storage. It doesn't store anything. In the computer, when the computer is on, the random access memory is available to use. Once the computer is off, whatever that is in the random access memory is gone. So it's more of a volatile memory, okay? It's not a permanent one. So the types of RAM is dynamic RAM and static RAM. You could also say it as DRAM and SRAM. So what of the features are mentioned in the table below? What is the full form? SRAM is static RAM, DRAM is dynamic RAM. What is the speed? The speed of the static RAM is faster, while the dynamic RAM is slower. The refresh needed in the static RAM, no. But for dynamic RAM, the refresh is needed, yes. The cost of the static RAM is expensive and the dynamic RAM is cheaper. Right. So where do we use the static RAM? In the cache memory. Where do we use the dynamic RAM? It's used in the main memory, okay guys? What is read-only memory? Now we discussed about random access memory. Now we are going to discuss about read-only memory. Read-only memory is the permanent memory, that is a non-volatile memory. You can say flash drive and then the external hard drive or internal hard drive in the computer as examples. So there are types of read-only memory, which is programmable ones and programmable read-only memory. The second one is electronically programmable read-only memory, erasable programmable read-only memory. The third one is electronically erasable programmable read-only memory. So programmable read-only memory is it's programmed once and it cannot be reused again. But on the other hand, erasable programmable read-only memory is you erase it using the ultraviolet rays and then you can rewrite the or overwrite with another data, okay? And then electronically erasable is it's pretty much the erasable programmable read-only memory, but it is erased electronically. So let's look at the memory hierarchy. Cache memory, main memory and hard disk, okay? So the smaller the capacity, the memory is faster. So the cache memory is faster. And then main memory is little bit slower than the cache memory, and then the hard disk is most slower among these three. Okay, what is cache memory? Very high speed memory placed between CPU and main memory. It improves performance fast. You know, in web development and all, you store information like the username and let's just say the theme of the user in the cache memory. Those are stored in the browser. So it's easier to retrieve. You don't have to go to the database and fetch those information every now and then. For every user, you store some of the things in the cache memory. Like for example, remember me in the login page, right? Username and password. It will be stored in the cache memory when you click the remember me button. So whenever you come to the same site the next time, you can directly go instead of entering the details, because those details are already in the cache memory. It will be fetched by the browser and then added there. But what will happen if you clear the cache memory? We know once the cache is cleared, all those information in the cache, for example the username, password, the theme of the user, and everything, it will be erased. You have to log in again. So the browser cache memory is an excellent example for cache memory. Okay, it does improve performance. Okay, let's go to the secondary storage. Secondary storage devices are the primary permanent storage devices, where you can write your data once and then you can retrieve it how many more times you want. So the examples are hard disk, CD, DVD, flash memory, and whatnot. Flash memory is pen drive, right? Compact disk. These are the older technologies. I'm not sure if you guys are familiar with those. So optical door storage devices like a CD disk, where you can store your data, like movies, right? That's what we use those for. Its capacity is about 700 MB. And then DVD is a slightly advanced version of the CD, where we can store up to 4.7 GB. This is an optical disk with higher capacity. Flash memory. This is a non-volatile electronic storage which is permanent storage. It has examples of pen drive and memory card. So Blu-ray disc, right? This is an another example for the optical device which is high density and it has the capacity above 50 GB. So let's go to the next slide. Ports and interfaces. What are ports? These connects external devices to the computer. Okay. Here are the types of ports. As you can see, the USB port. This is the most common one, we use it, right? To connect our computer to a mobile device, to connect our computer to another computer, for example, another storage device, like external hard drives. And we use these ports to connect to a printer or a modem or an external hard drive. So without those ports, we cannot connect these devices to our computer, right? So look at the pictures in the right corner. So there is the USB port, the serial port, and parallel port. We use this to connect CPU and a monitor, right? In a traditional computing device, we use this port, right? Serial port and then the parallel port. The next one is VGA port. That is another type of port which we use to connect to a video source. And then PS2 port. This is the round port, guys. This is the oldest of ports. We use these circle ports to connect the keyboard and the mouse back in the 90s. And then this is the HDMI port. This is the latest port, right? The newest one to connect to a monitor from the CPU. HDMI. And then we also can connect to TV using this HDMI port. Because today we have um, smart TVs, right? Which uses this HDMI port to connect between devices. So remember these things. So there are so many more, but these are the major ones. Okay. So USB and HDMI. USB, there is a difference between USB and HDMI. USB is connecting to devices like printer, scanner, and mobile, like I said. But HDMI, on the other hand, transfers audio and video signals. Okay, that is why we use the HDMI port to connect to a TV or a projector in many cases. So now we have seen about the computer organization and how, and explains how hardware and software hardware components work together, right? So in order to work, these hardware components must have, especially with respect to a computing device, it must have what, a chip, an Intel chip, which is a microprocessor, and you'll have input output devices which would be connected through ports, and then the information transfer happen through buses and external wires, right? One great example we saw was connecting to a modem through a computer, right? That is a bus. So how memory is stored, and how are we retrieving the information from the memory using registers. We saw about arithmetic logical unit, control unit, and the registers array, right? And then the types of memory, memory devices. What else did we saw? The buses, what are buses mean? So these are the hardware devices that we need to work with the computer. So in the next chapter, we will talk about the software, right? Be the operating systems software or the application based software. Okay, so in the next chapter we will be seeing much elaborately about the softwares. Okay, thank you.